In Part 1 of Lecture 3, we will discuss Unix files fundamentals. In the view of the Unix operating system, a file is a sequence of bytes, meaning 1 character, 2 characters, 3 characters, and so on, or it may be just simply 8 bits of data of another kind other than character data. But in either case, Unix doesn't impose any sort of structure on a file, and unlike Windows, where the file name extension is intended to tell you what kind of program is going to be making use of that file, file extensions are just another part of the name in Unix and, for that matter, Linux files. In Unix and in Linux, when you work with peripheral devices, they too are considered files. In the example that you see here, what you see is my opening the regular line-oriented editor ed. I typed A so that I can add some data to it, and over 2 lines I wrote, "Now is the time for all good people." Beginning the next line with a period, as before, takes us out of command mode, text mode into command mode. I then write W for write, and then junk is the name of the file. It tells you that I wrote it by seeing the number 36, indicating that there are 36 bytes. Q and quits. And if I go to do a long listing using ls space -l, you can see the listing for it. As we've already seen, the file junk has 36 bytes in it, and we can do a long listing as we did before. If I type cat junk, I'll see "now is the time for all good people," which is exactly what we had before. But if I use a different command, the command od, and the option -c, I'll see the file printed out character by character, and in this regard I can see over the file, "now is the time." I can see the \n indicating the new line for all good people. Now the numbers on the right hand side are the number of bytes from the beginning of the file in, of all things, base 8. But nevertheless, this gives us an opportunity to see the file in greater detail. OD is short for octal dump. Octal meaning base 8, dump meaning just spitting out byte by byte what the contents of the file is. Now there are 3 options that we have here. -c means that it will give me the contents byte by byte in character format. -o will give me the display in base 8. Now, we don't use base 8 very much anymore, and one of the main reasons is that with there being no 8s and 9s in it, it looks very much like a base 10 number. You have to look at a lot of it before you start realizing that there are no 8s and 9s. We have the option here of getting it displayed in hexadecimal using -x. Hexadecimal is a lot more useful, given the fact that 3/8 of all the characters are letters, A representing 10, B representing 11, C 12, D 13, E 14, and F 15. You don't have to spend a lot of time looking at numbers in hexadecimal before you recognize that you're going to have a few things there that you would not have in a normal decimal or base 10 number. Along the line, it'll also show us special characters. So the \012 will indicate that there's a new line. And this is a notation that's borrowed from the C programming language, one that you probably have already seen in C++ and Java. \010 is a backspace or \b, and similarly a carriage return. Carriage return we don't typically use because all that'll do by itself is take us to the beginning of the line. Typically, we will use the new line instead. Tab stops are normally used for when you are looking to get your data organized in table format. The name tab comes from table or tabular, of or pertaining to tables. STTY is set terminal. STTY and then space dash tabs will cause tabs to be replaced by spaces on some older systems. We're not going to worry about that here. Older operating systems rather, frequently will make use of a record of a standard record length format. So for example, if I were working on an old style IBM mainframe, I might recognize that my record length is supposed to be 72 characters or 80 characters or 45 characters. We don't have anything like that in Unix. CRLF is carriage return line feed. When you hit the enter key on a PC, there are two things that you'll notice, two actions that you tend to think of as one. You go to the beginning of the next line. Carriage return in a computer means literally that, having the cursor go back to the left margin. Line feed takes you to the next line. While these are considered one character, namely the new line on PCs running Windows, on Unix and Linux systems, these are usually taken as two separate characters, although \n is meant to be the combination of the two. Unlike other operating systems, where there may be a special character marking the end of a file, you don't have that in Unix and Linux, where the system keeps track of the number of bytes that you have making up a file. It may seem a little ironic, but believe it or not, despite the fact that the human user is the slowest part of any computer system, there are times that your typing is quick enough that the computer can't quite keep up with using all the characters you've typed in. There is a particular area of memory set aside in most computers called a buffer. A buffer is intended as a temporary storage location for data that is either coming in more quickly than you can make use of it, or is not going out as quickly as you are accumulating it. In the case of a keyboard buffer, what it means is it's taking each of your keystrokes and saving it there, and at the appropriate or relevant time, it will make use of it. Now, what you do with this is going to vary in different cases. We've seen the cat command as a command that allows us to write what we have in a given file. Now, in this case, without mentioning the name of a file, it's waiting for standard input. In other words, for what we're typing at the keyboard. So after I type cat, I type 1, 2, 3 and hit the enter key. When I hit the enter key, it will then take what I've typed and it will print it out. And I can do the same thing for 4, 5, 6, 7, 8, 9. What it is doing is literally echoing what I've just typed, because what it's doing is displaying what I've asked it to display on the screen. When you don't mention a file, most commands will assume that you mean standard input. Now, if I don't hit the enter key, what I can do instead in some cases is use the Control D. Control D stands for end of file, believe it or not. When you type that, what you're telling whatever program you're using is that there is no more additional data. A file can store a very large variety of different sorts of data. It can hold, for example, the grades that I'm keeping track of in a class that I'm teaching. It can keep track of my lecture notes. It can keep track of television programs that I want to watch. I can actually even save recordings on it, whether it's music or video. And it can even hold programs along the way. Now, the Unix system as such does not keep track of files in terms of what the files contain. In this regard, it's very different from Windows. The file name extension in a Windows file will give you a very good idea of exactly what it's storing. The file command tries to make the best possible guess. So in the case of /bin, it recognizes pretty quickly that it's a directory. On the other hand, /bin/ed, it recognizes quickly that it is an executable program, and everything else that it says here is related to that. The truth is that exactly what all of this means is something that's a little beyond the scope of the course, or certainly beyond our scope right now. Similarly, I can do the same thing for file args.c, and it recognizes from what it finds at the beginning of the file that it is a program written in C and that it's a text file. Args afterwards is telling you that it is similarly an executable version of a program. We spoke about the program file before, which makes an educated guess based on certain clues in the file as to what type of file it is. It can spot a C program largely because it does see the extension, although the operating system itself typically won't pay attention to that. And it also sees the use of braces, which are very common in C. It'll also read the first couple hundred bytes of the file looking for other clues. The Unix operating system, and Linux to a large extent too, makes use of what are called magic numbers. And in this particular case, the base 8 number 42577 is the so-called magic number. It'll indicate on this particular system an executable file. We started talking in lecture 1 about redirection, and we can use this together with any command. Redirection is processed by the operating system itself when it reads this. As a result, the program doesn't know anything about what you exactly typed or where the destination is for standard output. That's handled solely by the command interpreter of the operating system, or the shell as we call it. So in this particular case, what it will do is give me a listing character by character of the file junk, but it will be in the file temp. Now if I type ed ch2.1, it will allow me to edit the file, and what I'll do here is read the contents of that temporary file into the file that I'm creating. This is one of a lot of little tricks that you can do on a Unix or a Linux system. Early operating systems worked with a fairly limited number of structures that could be written into a file. The idea that there could be virtually no restrictions on a file was fairly new when Unix came out. And that is something of an advantage. You can pretty much do with the file structure whatever it is that you wish to do. The disadvantage is that you can do many things that the user may not necessarily want to do, and a good portion of them by accident. What this means is that the responsibilities regarding file format rest squarely in the hands of an application programmer. So if you are a programmer working on a Linux system, this pretty much makes you responsible for what it is that you are going to do.